Good morning, all of you. In this session of class 10 Cbse real numbers. So, real numbers is a chapter which all of you have already been doing for the last couple of months. It was the first chapter of your math syllabus of this particular term. Now, today I am going to share a PDF with you. Actually, in the description box below, there is a link to a PDF. That PDF contains 10 MCQ questions. And in this session, basically I will just tell you what are the techniques that you need to use to solve this PDF, and thereafter you can solve the PDF and only send me your answers. You just need to send me your answers, the working is not needed, and now of course I'll tell you whether they are correct, right? So let's begin the session. So in real numbers, probably the question which has come the maximum number of times is the fact that using the division lemma, we can say that any even number will be of the form 2n and any odd number will be of the form 2n plus 1. So this is a direct outcome of the division lemma, right? So any even number from division lemma, we can say that any even number can be written as 2n and any odd number can be written as 2n plus 1. Now suppose let us say that you have an expression like this, n square minus 1. Let's say you have an expression n square minus 1. So you can write it as n plus 1 into n minus 1. Now let's say you have been told that n is odd, okay? So you have an expression n square minus 1, which is basically n plus 1 into n minus 1, and let's say you have been told that n is odd. So if n is odd, then this is odd plus 1, so obviously that's even. This is odd minus 1, again that is even. So you have product of two even numbers, right? Another thing, n plus 1 and n minus 1, they have a difference of 2. If you subtract n plus 1 and n minus 1, you will get a difference of 2. So that means n plus 1 and n minus 1 are consecutive even numbers. Another thing you have to remember, that consecutive even numbers, if one of them is a multiple of 2, the other one has to be a multiple of 4 as well. It is compulsory, because let's say for example, if n minus 1 is 2, then n plus 1 is 4. If n minus 1 is 4, then n plus 1 is 6. If n minus 1 is 6, then n plus 1 is 8. So out of the two numbers n minus 1 and n plus 1, one of them may be just a multiple of 2, that's all. But the other one in that case will definitely be a multiple of 4. So out of n plus 1 and n minus 1, one of them is a multiple of 2, right? So multiple and the other one will definitely be a multiple of 4. So the product will be multiple of 8, right? So if n is odd, then n plus 1 into n minus 1 is multiple of 2 into multiple of 4, and the product is multiple of 8, right? Now this is a concept that whenever you have an odd number n, then n square minus 1 will always be a multiple of 8. So this is a concept which you will require in the PDF. The PDF which is, the link to which is given in the description box below, right? The next kind of question is that suppose you have two numbers, 65 and 117. Suppose you have two numbers 65 and 117, and first thing you have to do is you have to find the HCF. So you know that using division lemma, 117 is 65 into 1 plus 52. Then 65 is 52 into 1 plus 13. and 52 is 13 into 4. Okay, so 117 is 65 into 1 plus 52. Then 65 is 52 into 1 plus 30, and 52 is 13 into 4, and plus 0. So the HCF will be 13. This is a very basic technique to find HCF using the division lemma. So the HCF of 65 and 117 is 13, right? Now, what is the question that we are going to do? The question we are going to do is that, can we express this HCF as a combination of the two numbers 65 and 117? That is the topic. Is it possible to express the HCF, which is 13, as a combination of the two numbers 65 and 117? That is what we are going to discuss. Let's see. So what we can do is, from the first step we can say that 52 is 117 minus 65 into 1. Now what you have to do is, you have to take this 52 and put it here. So 65 is 117 minus 65 plus 13. So ultimately 13 is 65 into 2 minus 117. So we have managed to find 13 as a linear combination of 65 and 170. Linear combination means 65 into some integer plus 117 into some integer is equal to 13. We have managed to get that. So this is a technique based on which you can have a few questions. So the point is that, so basically 52, you first write 117 minus 65 into 1, then 65, you do one thing, you just go to this equation, you replace 52 as 117 minus 65 into 1 plus 13, so finally 13 is 65 into 2 minus 117. So this is how you can express the HCF of two numbers as a linear combination of the two numbers, right? So this is another topic which will help you to solve the PDF in the description box below, right? Okay. Then there is a question in the PDF in the description box below. There is a question that which is the least natural number which is divisible by every natural number from 1 to 10. So which is that least natural number which is divisible by every natural number from 1 to 10? That is a question. So what you have to understand is that if you take 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, so you take 5, okay, then you take 9, you take 8, you take 7, and since you have taken 8, you have already taken 2 and 4, since you have taken 9 and 8, you have already taken 6, 1 is of course, anything into 1 is 1, so we don't really bother much about 1. Since you have taken 9, you have taken 3. Since you have taken 8 and 5, you have taken 10. So the point is that you take these numbers 5, 7, 8, 9 and multiply them. So if you multiply 5 into 7 into 8 into 9, the answer will come 2520. So the question is that which is the least natural number which is divisible by every natural number from 1 to 10. So for getting the answer, you know that the prime factors are 2, 3, 5 and 7, and then you have to take the highest power of every prime factor. So I have taken 5, 7, 8, 9, it has come 2520. So the answer of this question is the least natural number is 2520. So this is another question which is given in the PDF, the link to which is in the description box below, right? Then the next concept that will help you to do this PDF, you know that 1 by 5 is actually nothing but 2 by 10, 1 by 25 is nothing but 4 by 100, 1 by 125 is 8 by 1000, 1 by 625 is 16 by 10,000, 1 by 3125 is 32 by 1 lakh. So basically 1 by 5 is 2 by 10, 1 by 25 is 4 by 100, 1 by 125 is 8 by 1000, 1 by 625 is 16 by 10,000, 1 by 3125 is 32 by 1 lakh. So if you basically keep on taking multiples of 5 in the denominator, then you will get multiples of 2 in the numerator. This is the theory. So say for example, if you are asked to do the decimal representation of this number, suppose you are asked to do the decimal representation of this number 14587 by 1250. So you have to multiply above and below with 8, because for 125 the answer is 8 by 1000. So if you multiply above and below with 8, then you will get 116704 divided by 10,000. So that is coming to 11.6704, right? So 14587 into 8 is 116704. So 116704 by 10,000. So answer is 11.6704. So the decimal representation of a number, you can get it if the denominator is a power of 5. You can get it by making this kind of adjustment based on this chart. So these are the theories that will help you to solve the PDF which is given in the description box below. So please try the PDF as a homework. You can send me your answers. There's no need to send detailed solutions. And I'll keep posting videos like this with attached PDFs which you can try for homework. So that's all, and thank you very much. I'll end the session. Bye all of you.